Good morning, children. Stay safely at home. So today I am starting the next chapter, sources of energy and nuclear fission and fusion. So this is nothing new to you. Already you know what is nuclear fission and fusion. Few more details you have to know in this chapter. And this chapter is also a very small chapter, interesting chapter, scoring chapter, and important for your exam. So I am starting with nuclear fission reaction. So what is nuclear fission reaction? Nuclear fission means when a heavy nucleus, after capturing a thermal neutron, it splits into two almost equal nuclei. Then that process, that reaction is known as the nuclear fission reaction. Now, nuclear fission reaction is a nuclear reaction. So, in this one, it obeys the energy mass equivalence theorem. E is equal to delta mc square. And as you know that whenever a small amount of mass is converted into energy, it produces a large amount of energy. Alright. So, the same thing takes place in nuclear fission reaction. So, typical example of nuclear fission reaction is that when a uranium-235 is bombarded by one neutron, then what are produced? Barium, krypton and 3 neutrons. So here, this is the specialty of a fission reaction, that one neutron is taking part in the reaction, but as a product, how many neutrons are produced? 3 neutrons are produced and lots of energies are produced. So, related with the nuclear fission reaction, what are the points you have to remember? I have just noted down here. First is the definition of the nuclear fission, that is the process in which a heavy nucleus, after capturing a thermal neutron, splits up into two lighter nuclei of comparable masses. That is known as the nuclear fission reaction. Alright. So here I have written nuclear fission, the process in which, but I have not written is known as nuclear fission because already written there. So if the definition comes in exam, how to write? Nuclear fission is the process in which. Alright. Okay, I can do one thing here. I can just rub it and you can write that nuclear fission. This is the definition of the nuclear fission reaction. Then the second important point, this question also, okay, means frequently it comes in the exam. What do we mean by thermal neutron? Thermal neutron means the neutron which possesses 0.027 electron volt energy. Alright, that type of neutrons are known as the thermal neutron. Thermal neutron means which possess 0.027 electron volt energy. That is thermal neutron. So this is another important point. I have noted down all the important points that you need to learn and remember for your board exam. Okay, so this is the second point you have to remember. Then third one, this is a typical nuclear fission reaction. You see 92 uranium-235 plus 0N1, 0N1 is neutron. Then it splits into barium and krypton. 56 is the atomic number, 141 is the mass number of barium and krypton 3692. And here, this is the most important part. 3 neutrons are produced and delta E represent the large amount of energy produced during nuclear fission reaction. Now the question arises, how much energy? Energy released per fission. Per fission means what? For one uranium-235 nucleus, roughly 200 mega electron volt energy is released. And 200 mega electron volt means 3.2 into 10 to the power minus 11 joule. Now you may think that what Miss is saying, that nuclear fission reaction, large amount of energy is produced, but it is of the order of 10 to the power minus 11. But you have to understand it, that one uranium nucleus is producing so much energy. Alright. Now if you take 1 gram of uranium nucleus, then in 1 gram of uranium nucleus, 2.56 into 10 to the power 21 atoms are there. Okay. Means if you take only 1 gram of uranium 235, then in it 2.56 into 10 to the power 21 atoms are there. So you see how much energy will be released. 3.2 into 10 to the power minus 11 into 2.56 into 10 to the power 21, which is almost equal to 2.28 into 10 to the power 4 kilowatt hour. You have understood? 2.28 into 10 to the power 4 kilowatt hour of energy. Alright, so it means that nuclear fission, it can produce a large amount of energy because it is a nuclear reaction. So it can produce a large amount of energy. Now the next concept is chain reaction. So you have seen that in nuclear fission reaction, during each reaction 3 neutrons are produced. Just you consider this one, that whenever one neutron, thermal neutron, is bombarded the uranium 235 nucleus, then in the second step 3 neutrons are produced. So these 3 neutrons will bombard again 3 uranium nucleus. So what will happen for each bombarding, again 3 neutron will be produced. So you see, in the first step 1 neutron is taking part. In the second step, 3 neutrons are taking part. Then in the third step, 9 neutrons are taking part. Then in the fourth step, 27 neutrons are taking part. Then in the fifth step, 81 neutrons, 81 neutrons are taking part. It means what? That the reaction will continue as a chain. So this is known as the chain reaction. Alright. But if you consider the chain reaction, then what happened? So you see what is happening, that whenever the reaction started, once the reaction started, then every step the reaction is getting multiplied. Not only that, it continues as a chain. So that's why this kind of reaction is known as the chain reaction. Alright, means neutron is every time 3 neutrons are produced by one reaction, so the rate of reaction increases and rate of energy released also increases. So this type of continuous nuclear fission reaction is known as the chain reaction. Alright, but one thing is there, for the chain reaction there are certain difficulties to continue the chain reaction. Alright, what is the first difficulty to continue the chain reaction? That in the first one, when the neutron is bombarding, uranium 235 is bombarded by 1 neutron, then the neutron produced, it is having 2 mega electron volt energy. Alright, so 2 mega electron volt energy means the neutron, it moves very fast. So you know that whenever any particle is moving with a very high speed, then it may happen that when it is touching the other uranium nucleus, it may not be able to split into 2 parts. Alright, means what? If the fast moving neutron, their energy is not reduced below 1 mega electron volt, then instead of producing the second set of reaction, what the neutron will do? It will just pass through the uranium piece you have taken. Alright, means what? That the second step of reaction will not be there, and if the second step of reaction is not there, then chain reaction will be stopped. So this is the first difficulty of the chain reaction. So if you just pointwise want to write what is the first difficulty to continue the chain reaction, that during the nuclear fission reaction, what happens? The neutron released, it is having 2 mega electron volt energy. So the energy should be reduced below 1 mega electron volt. And if the energy is not reduced below 1 mega electron volt, then what happens? That next set of reaction will not start, will not be continued. Alright. So what is the remedy? How you can remove this difficulty? Already you have studied in 10th standard that inside the nuclear reactor we use one device that is known as moderator. So I have not written it on the board. You must note it down. Alright, here these are the 2 points you must write down, that during each fission a first moving neutron of energy, I have written within the bracket, 2 mega electron volt is released, but for fission reaction, energy needed per neutron should be less than 1 mega electron volt. Okay. Then next point, I am verbally saying, everybody note it down, that how you can remove this difficulty by using moderator. Alright, you note down the point this way, that this difficulty is removed by using moderator. Then next question will arise, what is moderator? Moderator is the device which slows down a fast moving neutron. Alright, what is a moderator? Moderator is the device which slows down the first moving neutron. Alright, so what is the material generally we use for moderator? We use graphite rod as a moderator. Clear? So 2 more points. Again I am repeating 2 more. Verbally I am saying, please you note down 2 more points, that how this difficulty of the first moving neutron is removed by using a moderator. Then next point you write down, what is a moderator? Moderator is a device which can slow down a first moving neutron. A fast moving neutron can be slowed down by using a moderator. Then the next point, what is the material we use for moderator? The material we use for moderator is graphite. Alright, graphite is used as a moderator. So this is the first difficulty of continuing a chain reaction. Now the second difficulty is to continue the chain reaction is that if you consider the first moving neutron that is emitted in the first step of the nuclear fission reaction, as it is the first moving neutron, due to its higher kinetic energy, it will travel at least 10 centimeter before getting slowed down and before getting ready for the next step of reaction or to continue the chain reaction. You have understood? That's why you see, if the fissionable substance you have taken, if the size and the amount of the fissionable substance is quite small, then what will happen? The neutron that is coming out, the first moving neutron that is coming out after the nuclear reaction, before producing the next step of reaction, simply they will move out of the substance and the chain reaction will be stopped. Alright, so that's why what is needed, that a minimum amount, means if you take the fissionable substance, very small amount, then chain reaction will be stopped. That's why a minimum amount, minimum size of the fissionable substance is needed to sustain the nuclear chain reaction, the fissionable reaction, the fission reaction. Alright, so that's why that is the second difficulty. Here the first point I have written, that is the second difficulty in sustaining the chain reaction. What is that? The neutron released in first step moves 10 centimeter. This is the important point to remember, 10 centimeter before slowing down. Therefore, if the uranium block to be fissioned is of very small size, then what will happen? Chain reaction will be stopped. Alright. So, what is the removal? How you can remove this difficulty? You take such amount of substance, fissionable substance, which can sustain the chain reaction. So, that minimum size of the uranium block which can sustain the chain reaction is known as the critical size. Important definition. And the mass of the substance of critical size is known as critical mass. So definition of critical mass, definition of critical size. Then what are the difficulties in continuing the chain reaction and how you can remove? These are the important point for your board exam. So you must note down these points, you must learn this point, and you must practice and retain the points. Okay. Then the next point is, you know already, there are 2 kinds of chain reaction, uncontrolled chain reaction and controlled chain reaction. So what is uncontrolled chain reaction? the chain reaction which is allowed to continue in its own way. Means in the first step 3 neutron, and in the second step 9 neutron, then third step 27, next step 81. This is the way the rate of reaction is getting multiplied, as well as rate of energy released at each step getting multiplied is known as the uncontrolled chain reaction. An uncontrolled chain reaction is not at all permissible because it is destructive by nature. Generally, in atom bomb, uncontrolled nuclear fission reaction is produced. This point also you have to keep inside the brain, and you have to remember it, that where uncontrolled nuclear fission reaction is produced in atom bomb, in producing atom bomb, uncontrolled nuclear fission reaction is produced. But if you can control the nuclear fission reaction, if you can control the rate of reaction, rate of energy produced, then by using nuclear fission reaction, a large amount of electrical energy can be produced. And already in 10th standard you studied that nuclear reactor is the device where a controlled nuclear fission reaction is produced. So, I repeat, these are the points, you must note it down. Verbally I am saying. So, those who are really want to score good and want to perform better in exam, please note it down. That what is the point I said? That in nuclear reactor, controlled nuclear fission reaction is produced. Alright? And already we have studied detail about the nuclear reactor in 10th standard. So now I will not go to all the details. I will not even draw the diagram because everybody knows it. I'll just tell you the important points. Now it is your duty to note it down, the important points. Okay. So what is nuclear reactor? It is a device by which, it is a device in which by using a controlled nuclear fission reaction, electrical energy is produced, or rather we can say that nuclear energy is converted. It is a device by which nuclear energy is converted into electrical energy. Alright. And what type of reaction? So what is nuclear reactor? The device by which nuclear energy is converted into electrical energy. Then second important point related with the nuclear reactor. What kind of reaction takes place within the nuclear reactor? What is the answer? Controlled nuclear fission reaction is produced. Then there are different fissionable nucleus, just uranium-235, uranium-238, plutonium-239. Okay, 3 fissionable, most easily fissionable products are what? They are uranium-235, uranium-238 and plutonium-239. These are the 3 products, but we prefer uranium-235. Alright. Then, inside nuclear reactor, what are the different parts of the nuclear reactor? The first part of the nuclear reactor is the nuclear fuel. What is the nuclear fuel? Simply a uranium rod, enriched uranium rod. Enriched uranium rod means what? You know that in uranium, means naturally occurring uranium, percentage of uranium-235 is less and percentage of uranium-238 is more. But as uranium-235 is easily fissionable because the energy needed is less, the neutron, thermal neutron which can break uranium-235, it is of the order of 0.0237 electron volt. Already I wrote and rubbed it. That is known as the thermal neutron. So what is done? There is a process that is known as enrichment. By enrichment, what is done? Percentage of uranium-235 is increased in the naturally occurring uranium means block. Okay, that is the process is known as enrichment, and enriched uranium rod is used as a nuclear fuel within the nuclear reactor. Alright, then second step is, what is the second component we need? That is moderator. Moderator, what it does? It slows down the high speed neutron, it just lowers down the energy of the neutron below 1 mega electron volt. Okay, what is the material used as moderator? Graphite. Okay, then next is controlling rod, very important point. Frequently the question come on it. What is the controlling rod? The rod which absorbs the extra neutron at every step and keeps the rate of reaction constant. So again I am repeating, saying it slowly, you please note it down. What is controlling rod? The device which controls or which keeps the rate of reaction constant by absorbing the extra neutron at every step of nuclear fission reaction. Alright, and what are the materials used for controlling rod? Cadmium and boron. Okay, what are the materials we generally use for the controlling rod? That is cadmium and boron. Clear? Then the next part of the nuclear reactor, next component of the nuclear reactor is coolant. So what is the coolant? You know that whenever nuclear reaction takes place, a large amount of energy is produced. Now this energy is produced mostly in the form of heat energy. Alright. So the chamber within which the nuclear reaction is taking place, therefore the chamber within which the nuclear reaction is taking place, heat should be taken out from it. It should be cooled down. So the next component is known as coolant. What the coolant does? It carries the heat from the chamber to the outside of the chamber. Alright, that is known as coolant. And what is the material used as coolant? Heavy water. Heavy water means what? H2O is the normal water and D2O. Instead of hydrogen, protium, if the deuterium is used, then that is known as the heavy water. Heavy water generally used as coolant in nuclear reactor. Alright, so these are the different components, different parts of a nuclear reactor. And in the nuclear reactor, what kind of reaction is used? That is controlled nuclear fission reaction. Now the next topic is nuclear fusion reaction. So what is nuclear fission reaction? When two or more than two lighter nuclei, okay, I repeat, lighter nuclei are combined together to form a heavy nucleus, then that process is known as nuclear fusion reaction. Alright, now what is nuclear fusion reaction? The definition you have to learn, and the typical example of nuclear fusion reaction I have written here. That also you try to learn and remember. You see here two deuterium nucleus, when combined together, it produces a tritium nucleus, one proton means protium, and 4 mega electron volt energy. Here is the main thing. How much energy? 4 mega electron volt energy is produced. Alright. And what is the definition of nuclear fusion reaction? That when two or more lighter nuclei moving at high speeds are fused together to form a single nucleus, then the process is known as nuclear fusion reaction. Now, it is very difficult to have nuclear fusion reaction in the lab, in our labs. Why? Because just try to understand, two lighter nuclei, they have to move towards each other at very high speed. Alright, so how much speed? If you want to create that speed, what is the minimum temperature needed? 10 to the power 8 Kelvin. Just remember, try to imagine it. This is 10 to the power 8 Kelvin. That is almost equivalent. That much of temperature only available in sun and other stars. Alright, so that high temperature, not only that, when they want to fuse together, combine together, then also what is needed? High pressure should be applied. Then only they will come closer with each other and will be fused with each other. Alright, so that is the difficulty of having the nuclear fusion reaction. That's why if you want to have nuclear fusion reaction on Earth, then to create that temperature temperature, first of all you have to take the help of nuclear fission bomb. Means by means of a nuclear fission reaction, you have to create that much of temperature, then only you can have a nuclear fusion reaction inside the lab. Alright, so that is the main difficulties of nuclear fusion reaction. So now the next point is coming. What are the differences between nuclear fission and fusion reaction? Already in 10th standard you studied. That's why I have not written on the whiteboard. I am just discussing point wise. Okay. And again I am saying, although I have not written in the board, but it is important topic for your exam. Verbally I am saying. So you please note it down. And you must note down the differences making two columns. So what are the differences? First point of difference between nuclear fission and nuclear fusion. In nuclear fission reaction, what happens? A heavy nucleus is bombarded by a neutron and thereby it splits into two almost equal nuclei. That is known as nuclear fission reaction. And in nuclear fusion reaction, what happens? Two lighter nuclei are combined together to form a heavy nucleus. Clear? Then, second point of difference is that in case of nuclear fission reaction, high temperature, high pressure not needed. Then in nuclear fusion reaction, high pressure and high temperature is needed to initiate the nuclear fission reaction. To initiate nuclear fusion reaction, high temperature, high pressure is needed. Then third point of difference is that nuclear fission reaction produces comparatively less amount of energy, whereas nuclear fusion can produce a large amount of energy. Okay, nuclear fusion reaction produce a large amount of energy per unit mass, and in case of nuclear fission reaction produces less amount of energy per unit mass. Clear? Then fourth point of difference is that in case of nuclear fission reaction, it can be controlled. Nuclear fission reaction can be controlled, but nuclear fusion reaction cannot be controlled. Alright? Then the next topic is that what is stellar energy? Stellar energy is the energy released by sun or all the other stars by means of nuclear reaction, because you know that the source of energy from star, and sun is a star, so from the sun or stars is the nuclear fusion reaction. What kind of nuclear reaction takes place in the sun or stars? Nuclear fusion reaction, because the main component of stars and the sun is helium and hydrogen. Alright, so nuclear fusion reaction takes place and it produces a large amount of energy. So the energy that we obtained by means of nuclear fusion reaction from the sun or the stars are known as the stellar energy. Alright, and then after that, how the stellar energy is produced, different kind of theories are there. That point is removed from your part so that you don't have to learn. So till now, whatever I have discussed from in this chapter, this is the end of the chapter. Please do learn each and everything, because it is a scoring topic, and the most important thing is that no numerical you have to do. Thank you, girls.